and part of the Principles of Object-Oriented Design course. In part one, we defined the Don't Repeat Yourself principle. We went through a number of demos showing how there was repetition in our code. We analyzed the code and looked for ways that we could improve it. And we made a checklist of problems that we found. We went through a number of refactorings to apply the Don't Repeat Yourself principle, and we didn't get through them all. So in part two, we're going to continue with those. And with this part, we're going to have an emphasis on testability. So at the end of this section, we'll have our code refactored to a state where we can easily apply unit tests to it. And we'll also examine some testing concepts, such as mocking. Next, in part three, we'll talk a little bit about code generation, some tools that you can use to eliminate repetition in your code and to discover repeat blocks of code, as well as how you can use automation to eliminate repetition in your software design and development processes. In part one, we went through these first four sections. We eliminated some magic strings and values. We found duplicate logic in several methods. We eliminated some repeated if-then logic, and we used polymorphism instead of conditionals. Go ahead and watch part one if you want to see some of those refactorings in action. Now we're going to jump down to the testing and static methods section. So look for, in this section, we're going to be talking about how we can use automated tests instead of just manual testing that we had previously. And also we're going to eliminate some static cling and get rid of a bunch of static methods and replace those with methods that are more easily tested. Finally, in part three, as I said, we'll come back and look at some additional refactorings, find some duplicate code using a tool, and also get into that automation of our processes. Without further ado, let's look at how we can add some testability to our code. Wrapping up our analysis of the application, we see that it has no tests. You may have noticed inside the various solutions that I've been working with that there are projects there for unit tests and integration tests, but right now they have no actual tests within them. The only way that we've been testing our code is through the use of manual tests, or in this case we've been just running the code over and over again, hoping that we still get the same result that we got when we started. As we add functionality, it becomes more and more expensive to verify that the results are correct, especially as the data gets larger or the number of different operations get larger. And if the time required to actually run the code gets longer and longer, our manual testing process gets more and more expensive as more and more time is wasted on these long-running queries. Another problem with this code when it comes to testing is the use of static methods. The static methods introduce tight coupling in an application because there's no way to replace through dependency inversion or similar procedures the code that's being executed within the static method. These are difficult to test because of these tight coupled dependencies, which oftentimes lead to third-party infrastructure things the code is tied to, like a database. And it makes it very difficult to change the behavior without actually going in and changing the code. It also limits our ability to use object-oriented design techniques such as inheritance and polymorphism because static methods inherently don't support those, at least in the C# language. Now it's worth noting that there are some third-party tools that will go and do some tricks within the code to make so that you can mock out or change what static methods do. But speaking only about the stuff that ships with the .NET framework and the types of code that you typically use to test the code, static methods are a problem. Let's look at a demo of how we can refactor this code to eliminate the static cling, or the use of static methods and properties, and also to add in some tests. And we'll look at some real quick unit tests and integration tests. The easiest thing to do with a tightly coupled legacy application that doesn't have a lot of abstractions is to start out by adding some integration tests. So we'll look at our integration test project where I've got a tests class. And the first thing we're going to want to do is verify that, let's say, extraction loads up the correct values for the things that it's doing. So extract, you can see that it's trying to get invoices after a certain date, and then it's trying to get the employee also from a non-employee table. So in this case, we can say something like extract should load invoices, and let's just say that should is our name. And then we can put in a public void row of invoices. And we'll call this a test. So it will run. And now we can go and try and test our code. So let's rename our class here, rename the file. And of course, there's no easy way to test our code at the moment because all the logic is inside the program is marked internal, and so it's very difficult to get to this code. So the first thing that we need to do is try and extract that extract method into something that we can work with. And so to start with that, we'll create a new class. And we'll call this class extraction service. And we'll simply move this entire block of code into that service. And we'll keep it all as a static method. And now here we just call extraction service.extract. Now the problem is that our extraction service needs to actually pass back some of this data. This employee table needs to come back, this invoice table needs to come back. So instead of having a void, we're going to create a new result, or extract result, and it has a public data table, invoice table, and a public data table, employee table. There's a number of different ways that we could do this, but this one will work. And then in our method, we'll say that we need a var result equals new extraction result. And then we'll set this to be result.invoice table. Place that everywhere. Similarly, the employee table will be result.employee table. Place that everywhere. And then instead of void, we need to return extraction result, which means that down here at the end, we return result. And here in our code, we will also save our result equal to this. That's public. Good. And then we need those to be our local values. So we'll say that employee table equals result and invoice table equals result invoice table. Now we hope that that still works, so we'll try and build, try and run. Code still runs with our manual test. So now we can go into our here, we can do the same thing. We say var result equals we've got our namespace extraction service dot, there we go, the namespace dot extract. Now you can imagine that I'm going to be talking to a different database. So let's go ahead and we'll run this test right now and we'll watch it fail. So run our unit test. And it's failing right now because it could not load the assembly. Or dependencies, right? Now at this point we can actually run our test, and it should work because we're using hard-coded connection strings within our program. So when we talk to this database here, it's going to be talking to the same database that our live application talks to. Now obviously we've got another to-do item to pull this out into some kind of configuration value, and then within our integration test, we would change that out to talk to a test database. But for now, let's go ahead and run this unit test. And here you can see that we got our output. The other thing that we can then do to make our test actually valuable is we can start asserting something about the results. So we can say assert dot are equal result dot employee table.count, or rather, rows.count. And for now, we're just actually trying to put our system under test so that we know that it does what it does. So we expect it to be some number, and we're going to verify whatever that number is here in just a moment. So we'll change this to the invoice table. We know it's not 0, we're going to set it to what it really is. So 2155 is the number that got back for invoices. Yep. Accept that. And we run it again. And we have 9 employees. We'll put that here. And we've got a successful test. So this is our first integration test now that we can run. And this basically verifies very little. It proves that we're getting back the number of rows that we expect. And it's the reason why we expect it is because it's the amount of rows we get back currently. This is called a fixing test because it fixes what our application does and what we expect it to do at this point in time. And it lets us continue to make changes now, confident in the knowledge that when we run this test, it will verify that the behavior that the system currently does has not been changed. These are nice to have when you're going and doing a large refactoring, because the purpose of a refactoring is to change how your code is designed and how it interoperates, but not to change its behavior. So you expect that whatever it was doing previously, it's still doing. And so these are valuable from that point of view. However, they are very slow tests. If we look at the time that this test took, run it one more time. And we can turn on timings here. You can see that this test took about a second to run. Now, it doesn't sound like that's too bad, but as we continue to add tests to this, we're going to have hundreds of tests. And if our code takes hundreds of seconds to run, it's going to get very, very slow to run these every time we want to do a checking, or every time we want to verify that our code still does what we expect. So the other thing that we want to do is add some unit tests to this code. So if we look here now at our unit test code, we can change what this class is doing. Say something like extract should as well. And what we want extract to do is simply to get some data from these two data sources. And we don't really care what that data is in this case. So we're going to do some additional refactoring in order to get to the point where we can do this test. But basically we want to have something like our extraction service. First we need a method. So we'll create a method for our test, and we'll say extract should get data from invoices and employees. Make this a test. And then we can save our service equals new extraction service and our reference. And we want to basically, this is going to use a pattern called arrange act. So our results equals service dot, and actually we don't have that as a non-static method yet, but we will in a moment. So we'll just leave this right here for now. And then we'll have our assert. And in our assert, we can verify that this gives a code. In this case, we'll say something like assert dot is not null, and it's going to be our result. So for now, we'll just say new object. Right. So there's not much here yet. Let's go make it so that we can actually run this unit test and verify it's doing the interactions that we expect. Now, the thing about the unit test is that it's not going to have a kind of a reference to system.data. It's not going to talk to the database at all. And the way we're going to achieve that is through the use of something called mock objects. And we'll see how those work in just a moment. Or through the use of fake, which we could also use. So we'll show both those. So let's go back to our program. We've got this extraction service. At this point, let's move that to another file. And we've got our result. We'll move that to another file as well. And in our service, we can see that it's talking to a database, doing two commands. Basically, it's going to need to talk to an invoice table, and it's going to need to talk to an employee table to do these things. So I'm going to go ahead and say that this is a non-static method as our first reactor. And let's see what that breaks. Well, first off, in program, I'm going to have this be a new extraction service for that to work. And same thing in our integration test we just wrote. And then it's a good idea to run all our tests, verify everything still works. And they still run. So we can continue with our refactor. We come back to our service, which is now non-static. And we need to say that it depends on some things. So we're going to say, well, we need a constructor. And our constructor is going to say that we need an interface for, I think, something like invoice repository. And invoice repository needs to be able to return back let's say, a data table. Keep things easy. So it's going to have a data table, list invoices. We could specify the date we want, but for now let's leave that hard coded, which is the simplest that works. And we'll also need a derived type of this. We'll call this a SQL invoice repository, and we'll make it implement the member. And then here, we basically want to refactor out all this stuff that's using a connection. Grab all that, stick it into our list invoices. And once we get to the point where we have an invoice table here, we're going to return it. Actually, that's not quite right. We need a table there, then we need to fill it. So say var table, and then we'll fill that table, and then we'll return that table. Alright? Now, once we have that, we can come back in here and we can say, you know what, I need an invoice repository called invoice repository. I need a local variable set to that. So I've got now an invoice repository that's set to that. And I need this to work even if nothing is passed in so that my code still works the way it always did. So we're going to have a public extraction service empty constructor, which calls this and passes in a new SQL invoice repository. And then does nothing else. So this ensures that my code still works the way it always did. This is a poor man's dependency injection here. And then in our code, we only need this for each once we get our invoice table. So we'll pull this out. We need this result. And we need to say result dot invoice table equals invoice repository dot with invoices. And we can now get rid of this big using block. Next, we want to do the same thing with the employees. So we'll just get these out of our file. Move this to another file. Go back to our service. Move this to another file. Go back to our service. Create a new interface for employees. So we have a public interface employee repository. And it'll have a data table for list employee. Now we just need to create a derived type from that. We'll call it SQL employee repository. We'll implement members. And we'll do the same thing we did before. We'll pull out all this code here and drop that in. And we'll need to have a table that we built. And of course, you can see there's some duplication here that we would get rid of. Three methods already shown in other demos. We'll fill the table, we'll return that table, and then change our code here, take in that repository. So employee repository, we're going to introduce and initialize a field, employee repository, just as we did before. We're also going to change our poor man's injection to automatically inject a SQL employee repository. So our code continues to work as it did before. And then we need to say that our here, get rid of all the SQL stuff, and those closing curly braces, and we just need to say that result.employee table equals employee repository dot list employees. Now, another instance of don't repeat yourself that you might note here that I might change at some point is I've got employee repository and then I've got list employees. That gets to be kind of redundant. So it's pretty common to simply call this a list method instead. And now you know it's listing employees because, well, it's an employee repository. For now, we'll leave it the way it is and verify that we can still run our code. It still runs. Of course, we should be also able to verify that by running our unit test, which right now is just this integration test, and it still runs. Which brings us now back to our unit test. So our unit test, let's go ahead and rename our file. And that's good. Now we're able to actually call our service. So call service.extract and get some result back. And since we didn't pass in any kind of variables in here, right now we're going to be doing the same thing with our integration test. So now we can verify result. And running this should run just like our integration test. It does. You need to get all this data from our actual database. We don't really want to be talking to the database though at all. We really just want to verify that our methods were called. So what we're going to do is we're going to create a fake repository for invoice. So we'll say public class fake invoice repository inherits from I invoice repository. And we implement that member. And in this case, we just want to verify that this was called. So we're going to return a new data table with nothing in it. But we're going to have a boolean here. So public bool was called equals false. And we can set was called equals true. We'll do the same thing for our employee class. So we'll have a fake employee repository inherits from I was the repository. Implement its member. And here we'll say what's called equals true. Return new data table. Now in our unit test, we can pass in these particular repositories. So we'll say var invoice repository equals new fake invoice repository. Var employee repository equals new fake employee repository. And we'll pass these into our code now. This is using strategy pattern to inject these dependencies. And once we go to assert, instead of asserting against the result, this is called state-based testing, where we're testing that the state of our system is what we expect. What we're going to be doing is something called behavior-based testing. We're going to verify that the code under test, this extract method, did the things that we expected it to do in terms of its interactions with other code. So all I want to assert here is that invoice repository was called, and assert that employee repository that was called as well. And now we can run this test. And you can see that it ran in 3 milliseconds and came back as true, showing that these two things were in fact called, and it did not talk to the database. So that's an example of refactoring our code to allow for behavior-based testing. Now, if we looked at our service again and said that maybe based on the invoices, we would or would not call the employee table, we can see how that might change our unit test. So we could say something like, if result invoice table rows count equals greater than 0, then we expect to call this. This is the kind of logic that we would be testing with our behavior-based test. Because now we can come back to our unit test and know know that we're passing back an empty data table for an invoice, so we're going to expect this to be false in that case. So now we can run this unit test and see that it does what we expect. So that's an example of how we would test the behavior of the method of test, the extract method, separately from what the actual data is that it might be returning. And that wraps up our changing of static to instance methods, as well as some refactoring to get these interfaces. Move this interface to another file, go back to our service, move our repository to another file. And before we're done here, let's look at what we have. We've got now our program has gotten a little bit smaller. It no longer has the extraction stuff in it. Instead of using the extraction service, we've got a couple of invoices, which we've probably moved to a separate folder. We have a couple of implementations of those interfaces, which we would probably move to a separate folder, or ideally to a separate assembly that would be responsible for our data access. And now we've got both integration tests that talk to the database, as well as unit tests that verify the behavior of the particular method that we're looking at. Let's talk about how we could use a mock object instead of having our own fake objects to change how we would do this unit test. And then we'll be done with a section of the module. So, using a mock framework, like MOQ or MockQ, you can easily create mock versions of these interfaces that you can then use. So, in the case here where we want to verify that when we get back an empty result from the invoice repository, that we do not call the employee repository, we would implement that something like this. First, we need to change our invoice repository, make it so it is a mock one. So it says the mock of invoice repository. And likewise, we would like this to be a new mock of employee repository. And then we want to verify what this mock is going to do. So we'll say invoice repository dot setup, and we want to say that when the list invoices is called, we want that to return a new data table. Then we can do our service so that it takes in these things. With mocking, the actual object we want is under the .object property of our mock. So I'll say .object. For both of those, we're going to go ahead and call this. Now, instead of our assertion that we have this list called property, we don't actually have one of those on our mock object. Instead, we're going to say something like invoice repository.verify, and we want to say I such that I dot list invoices, and then we'll say times dot exactly one time. And we also want to verify, in this case, that the employee repository has a method called list employees that we'll say it was called times dot we didn't want it to have been called. We'll run the unit test, and we can see it was successful. So looking at this code, you can see it's doing pretty much the same thing we were doing with our fake objects here, except that you can imagine that we would end up writing a lot of these fake objects if we were doing this over and over again within our code. By using a mock framework like MockQ, we were able to create these mock objects, specify the behavior we expected from them, then pass them to our system under test, in this case our extraction service, run our code, then verify that the interactions with the collaborating objects, these two repositories, happen exactly the way we expected them to, with one call being made to the invoice repository, list invoices, and because of the result that it returned back, a data table with no rows, we were able to see that list employees was never called. And that behavior was this behavior we added here, as you recall. Alright, so that's how you can use mock objects. Obviously, we can go into more detail on that in another course. So to summarize, it's important to realize in our software development that repetition is a source of errors and waste. We should avoid repetition within our code by refactoring it so that there's only one canonical representation. And one of the fundamentals that I've found to be the most useful in doing this is the use of certain design patterns, such as the template method pattern or the command pattern. You can learn more about patterns from Pluralsight's pattern library, and also the dependency inversion principle, which we covered already in this Principle of Object-Oriented Design course. Some books that I recommend reading for additional learning about this topic is The Pragmatic Programmer from Journeyman to Master, as well as 97 Things Every Programmer Should Know, which has a bunch of very useful tips and stories from experienced software developers. Thank you very much. This has been part 2 of the Don't Repeat Yourself principle, part of the Principles of Object-Oriented Design course. I hope to see you in class soon. Hi, this is Steve Smith.